We're going to look at reference angles. We've looked at those a little bit before when we were doing our Ferris wheel activity. So in our Ferris wheel, we had something that looked like this, and then we had from here, we had these triangles that we were looking at. Ideally, they are all similarly spaced, but drawing's not my strong suit. So when we were looking at these triangles here, these four triangles really were the same four triangles, they just were reflected across or flipped in the Ferris wheel. Now what happens is we talked about this angle here to create this triangle, but what that really is what we call a reference angle. So this was our full angle of rotation, but we're referring to this angle to talk about our triangle here. And we did the same kind of thing with the straw activity. So our reference angle is an acute positive angle. So that means that it's less than 90 degrees. And it represents our given angle. The way that it represents the given angle is it's always drawn from the terminal side to the x-axis. That's really important that it's to the x-axis. Okay. So this is easiest explained with pictures. So if we look at this, 137, I first need to draw it so I have an idea of where it is. So 137 is in the second quadrant because it's past 90 but before 180. So our reference angle goes from the terminal side to the x-axis. So this right here is our reference angle. So to find that, we can take the full angle of 180 and then take away the 137, and that will leave us with this leftover part right here. So we can do the 180 minus the 137, which will get us to our reference angle, which then is just 43 degrees. Okay? Again, your reference angle is always acute and it's always positive. Okay? So if we look at this one, we're in the first quadrant. So this is 20 degrees, but our reference angle still goes from the terminal side to the x-axis. So not only is it the angle, but it's also the reference angle. So our reference angle is the same in the first quadrant because it is the angle. Okay. If we look at 260 degrees, that's going to be past 180 but before 270. Okay. Now, you have to be really cautious here because a common mistake is that it's closest to the y-axis, so we say it's just 10 degrees away from the y-axis. But we don't want the y-axis. The reference angle is always from the terminal side to the x-axis. Just like on our Ferris wheel, we were always going to the center of the Ferris wheel, or when we were doing our straw activity, we were always finding the height from the center. Okay. So you're always going to that x-axis. So on this one, this is our reference angle because it's going to the x-axis and not the smaller one. So that's something to be very cautious of. So to find this, we would just do 260 minus 180, which just leaves us with 80 degrees. So our reference angle is 80 degrees. Okay. Now in 340, we're in the fourth quadrant. So we're past 270, but before 360. Again, the way that we draw reference angle is to the from the terminal side to the x-axis. So this is our reference angle. And that gets us, if this is 360, this is 340, so we can really do 360 minus 340. Okay. So then our reference angle is just 20 degrees. Okay. Now in radians, our reference angles can be really quick because of the fact, if you remember, with our pi's, we have 0 pi, 2 pi, 3 pi, 4 pi, and it keeps going. So all of our odd pi's are on the left side, and all of our even pi's and 0 are on the right side. And this is true even if we go negatively, because this would be negative pi, negative 2 pi, negative 3 pi, negative 4 pi, and so on and so forth. Okay? Because of that, and we're always going to the x-axis for our radian, not what I want to say, to our reference angle, we are just seeing how far away from the nearest whole number the reference angle, or the radian degree measure is. Not radian degree, where the radian measure is. Okay? So if we look at this one, you can still draw and get your reference angle from there, but it's actually really quick to find the reference angle without having to draw it, which is particularly nice for our radians. Okay. So here, this is more than half, because half of 3 is 1.5 and 2 is more than that. So it's past a half, but it's before 1. So this is our 2 pi thirds. Our reference angle goes from the terminal side to the x-axis, so this right here is our reference angle. Well, if this is pi, we could get a common denominator, so 3 would be your common denominator between 3 and your unsaid 1. So 3 pi thirds is the same. So how far is it from 3 pi thirds to 2 pi thirds? Well, you're just pi thirds away, so your reference angle is pi thirds. Okay? Now, if you're saying, using the shortcut and just saying how far away from the nearest whole number, I can say, okay, well, it's more than half, so it's closest to 1. Well, how far away from 1? Well, because I want this to be 1, I want my top numerator to match my bottom number. So how many more do I need to go from 2 to 3? Well, I only need 1 more, so then my reference angle is 1 pi thirds. Now, if we look at the next one, I like to switch it to a mixed fraction and then evaluate from there. So 6 goes into 7 once. We've got 1/6 left over. Okay. So then I can just look at this number, and instead of drawing, I mean, you can always still draw. That's nothing wrong with that. But I can do it without drawing, which is nice. So this is closer to 1 because 1 is less than half of 6, which is 3. So since 1 is less than 3, I know it's closer to 1. Well, how far past 1 did we go? Well, we did 1 and 1/6, so my reference angle is 1 pi 6, which we just generally write as pi sixths. You do the same thing even if it's negative. So here I just say, how many times does 3 go into 5? Well, it goes in once, you have 2 left over, so that gives you 2/3 pi. So I have -1 and 2/3 pi. So again, I'm past a half because I know that this is half of 3 is 1.5 and 2 is more than that. So it's past 1.5. Well, how far away from 2 is it? Because that's our nearest whole number. Well, I only need 1 more to get to 3 on top, so I need 1 more third. So then my reference angle is 1 pi thirds, which we just typically write as pi thirds. Remembering that your reference angle is always positive. Now, if we look at 10 pi thirds, we can do 3 goes into 10 3 times, and I have 1 left over, so that's 3 1/3 pi. Okay. So then I'm saying, okay, well, is it closer to 3 or is it closer to 4? Well, half of 3 is 1.5. 1 is smaller than 1.5, so that means that it's closer to 3. Well, how far past 3 did we go? Well, we went past 3 by 1/3, so our reference angle is 1/3 pi, which is the same thing as pi thirds. Now, if we look at this row, we've got the same kind of thing that we will be doing. So pause the video, see if you can try this one. Okay, so you should have paused the video. So we're going to check. 8 goes into 9 once. You have 1 left over. So this is 1 1/8 pi. Well, was that closer to 1 or closer to 2? Well, half of 8 is 4. So 1 is less than that. So that means it's closer to 1. Well, how far past 1 did we go? Well, we went 1/8 pi past it. So our reference angle is just pi eighths. If we look at 13 pi ninths, 9 goes into 13 once, and you've got 4 left over. So it's 1 4/9 pi. So then we've got 4/9. We want to know, is that more than half or less than half? So half of 9 is 4.5, so it's less than that. Well, how far past the whole number did we go? Well, we went 4 pi ninths past it. So then our reference angle is 4 pi ninths. So here, 6/5, 5 goes into 6 once, you've got 1 left over. So this is 1 1/5 pi. So that means, since 1/5 is smaller than a half, that this is closer to 1. Well, how far past 1 did we go? Well, we went 1/5 pi past it, so it's just pi fifths. Okay. If we look at 15/7, that's 2 1/7 pi. So we're looking and seeing, is 1/7 more than half or less than half? Well, since half of 7 is 3.5 and 1 is smaller than that, we're just going to go that it's closer to 2. Well, how far past 2 did we go? Well, we went 1/7 past it, which is pi sevenths. Okay. Now, if I give you something like 13 pi tenths, okay, because all of these were going to the lower number, so you can see that it's just the leftover part of the mixed fraction that you're looking at. Okay. If I do 13 pi tenths, notice that 5. there we go, 13 pi fifths, sorry. So 5 goes into 13 twice, I have 3 left over. So I have 2 3/5 pi. Well, half of 5 is 2 1/2. 3 is more than that. So now this one, since it's more than halfway, we want to say how far away from 2, no, not what I wanted to say. How far away from 3 is 2 3/5. Well, because we're trying to get to the next whole number, I want to look at this part here, and I want to say, how many more do I need on top to get to a whole? Well, a whole would be 5/5, so I need 2 more to get to that spot. So then this would be, sorry, I didn't mean to scroll, 2 pi fifths as the reference angle. So if you're looking at the lower number, it's how far past it you went, or the leftover part of the mixed fraction. Okay. If you're going to the next highest number, you want to see how many more on the numerator to get. So it's matching the denominator, and that's your reference angle. So with your reference angles for radians, it's really fast to see what your reference angle is because of the fact that you always know that your odd pi's are over here and your even pi's are over here. So you're always going to the x-axis when you're saying how far away is the nearest whole number. Okay. So things to remember is that it's acute, so always less than 90, it's always positive, and it always goes to the nearest x-axis. So if I, like on this side, I wouldn't come back and say to this x-axis. So it's to this side x-axis because my angle's on the right side. Okay. And those are your reference angles.